Right. Our ultimate goal is to ping between R1 slewback and R2 slewback, between R1 and R2 slewback. We have to ping. And ping using VPN, which is going to be between router 3 and router 6. The advantage is you no need to run BGP on every router in the provider autonomous system 10. Autonomous system 10 is the service provider between our two sites. R1 and R2 are two different sites for us. Service provider is in the middle. Service provider need not to have full mesh if you have tunnel. That's one big advantage. R4 and R5 should be an MPLS supporting device. It need not to be a high-end router because we are not going to have any BGP or we are not having any VPN terminating there. VPN terminates only on router 3 and router 6. No BGP on router 4 and 5, so there is no chance of 4 and 5 learning customer route. As I said, we need MPLS. First step. Let me write down the steps first. Understand, we have already reachability. R3 is pinging R6. Let me show you that. Ping 6.6.6.6 using source 3.3.3.3. It is pinging. So using this reachability, we are going to form this VPN between the loopbacks. Before that, we have to enable MPLS. So MPLS is the first step that we're going to do. Let's do it. MPLS IP, interface F00, MPLS IP. You cannot enable MPLS on loopback interface, so don't waste your time. You see what happens if you enable in under loopback. It won't. Right? So don't waste your time. Show MPLS interfaces. You can see MPLS is currently running only on F00. There is no need to run MPLS between the provider and the customer, so don't do it. Don't enable MPLS on G30 on R3 and R6. Don't do it. Alright, so let us now go forward. Now, I'm expecting a neighbor with router 3. See, I can see the neighbor, LDP neighbor, MPLS have formed a neighbor with R3. Now, when I type this command, show MPLS LDP neighbor, you can see the port number 646 used. Look at this. There's a TCP connection. I said LDP uses TCP. Initially, to discover the neighbor, it will it will use UDP. Once the neighbor is discovered, it uses TCP connection. Now, very important thing is these two loopbacks should be a reachable address. See, router 4 picks 4.4.4.4 as the router ID. We did not mention this. We did not configure this. Likewise, router 3 has taken 3.3.3.3 as a router ID. Now this address need to be pingable. This 4444, if it is not pinging from router 3 cannot establish this neighbor. So in OSPF, router ID need not to be a reachable address. In OSPF, router ID need not to be there on any interface. It can be anything. In MPLS, router IDs are always loopback interface and it should be a pingable one. What are the other things you learn from here? You see the port number. On R4, the port number for establishing the TCP connection 32460. What do you understand from this statement? What do you understand from this line? What that is right. What story it tells you? Mm, mm, mm. Okay, I'll ask you another question. You have an envelope. Someone has written a letter. Some name is written here. Some name is written here. Let's say the name written here is 11111. That's the name written here. The name is written here 22222. What do you understand from this? Huh? Now, who is from and who is to? Hmm. So, sender is this and receiver is this, right? That the type of story is also shown here. What is that? Sender will always use a random port number. So it clearly says that it is R4 the one who initiated this TCP connection. Sender will use a random port number and the destination port number will be the port number of the service. Here the service is LDP. If it is Telnet, it will be 23. If it is HTTP, it will be 18. Because it is LDP, it's 646. Sender will always use random port number. So from this we understand it is R4 the one who initiated this TCP connection between these two routers. Why should R4 initiate? Is it not R3 the one which I configured first? If R3 is configured first, why R4 is initiating? Because, yeah, carry on. Someone was about to say. Ah, correct. Because the router ID is bigger. The one who router ID is big will be a designated router here. You can see that by typing this command show IP MPLS, sorry, show MPLS LDP, show MPLS interfaces. No, not in this command. Show MPLS. There's one command where we can see the designated router. It'll show like DR. Anyway, I'll, I'll I'll tell you when I find it. Hmm. 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 Yeah. Reachability is provided by OSPF. MPLS is not a routing protocol. That's why I said you need to provide reachability between the loopbacks because MPLS is going to use only the loopback interface as the ID to negotiate. Whether you enable MPLS on loopback interface or not, you cannot first of all. Even though you don't enable MPLS on the loopback interface, MPLS router will use the loopback interface IP address. And when it negotiates, it will always use its own loopback interface IP address. It will advertise its own loopback interface IP address to router 2, and router 2 should check whether I have reachability to 11111. If only then router 2 can send, oh, I say router 2, no, router 4. Let me repeat again. Router 3 will use its own loopback interface and send packet. Router 4 will check whether I know this 33333. It will check in the routing table. Yes, I know him. So now let me respond him because I know him. And also MPLS is running on this interface, so it will respond via this direction. So this loopback should be pingable. Pinging and the MPLS enabling on an interface has got no connection, no connection. Pinging is because of OSPF, Murli. All right, now let's enable MPLS on R5 and see. When I enable MPLS on R5, I'll see R5 initiating. Though R4 is already ready, MPLS IP interface range F00-1 MPLS IP, and this is on the router 6, last router. MPLS IP interface F0/0 MPLS IP. All right, now let's go to router 5 and check the neighbors. There should be two neighbors. Show MPLS LDP neighbor. And here we can see the one who initiated this is not router 5, I meant router 5. It is actually router 6, the one who initiated, because router 6 and router 5, if you compare, router 6 is bigger. But if you go a little top, between router 4 and 5, it is the 5 the one who initiated this, because 5 compared to 4, 5 is bigger. So whoever is big, they initiate. From the random port number, I know this. Next, the first point is over. Secondly, in order to have tunnel between R3 and R6, I need BGP. So I'm going to configure BGP 10. Where router 3 and 6, not 5. Router BGP 10. Actually, we need VPN. Please focus. Actually, we need what? VPN. I say address family IPv4, IPv4, sorry, not IPv4, address family VPN. No R5. We have to configure on router 3 and 6. Let me close these unwanted routers. 3. Thank you. So on router 3, router BGP 10, address family, listen, address family VPN v4 unicast. See, we call BGP as MPBGP. What does it mean? Multi-protocol BGP. BGP is not only going to be a routing protocol, it also does a lot of other things. It helps you to form a VPN, as you are going to do VPN now with BGP. See, VPN is always between two routers that are not directly connected. We all will agree. VPN is only for those two routers that are not directly connected. That is what VPN, no? Tunnel. Why do I need tunnel if I am forming neighbor with the immediate router? Not necessary. We are forming neighbor between R3 and R6. That's why I need tunnel. So to establish tunnel also, I can use BGP as a protocol. So this BGP can work with MPLS to provide you labels over the tunnel. So far I have just said router BGP 10, and straight away I said address family. I did not say any neighbor, you see. I came straight inside address family VPN v4. Now I am going to say neighbor 6.6.6.6. Remote neighbor 6.6.6.6. Activate. But the problem is, to activate this, I need to have a neighbor. So I go back one step. Let me see, I just took you there to show you why I need to create neighbor globally. Let me again go back. No router BGP10. I'm doing from the beginning. Router BGP10. I say neighbor 6.6. 6.6.6.6 so that I can activate this neighbor under VPN. That's my main intention. So I say neighbor 6.6.6 remote AS 10 neighbor 6.6.6.6 update source loopback 0 because we are forming neighbor using loopback. Now I'm going to say address family VPN v4 unicast and I'm going to call this neighbor 6.6.6.6 activate. That's the main intention of me creating these things. These things will bring up the IBGP session, but our main aim is not IBGP session. Our main aim is to have a VPN. But in order to have VPN, I need this IBGP session so that I can use that IBGP session with the same IBGP neighbor. I can negotiate this VPN. That's the right way of understanding this. But if you don't understand, then at least understand like this. In order to have a VPN with a neighbor, you should have an IBGP session already. This is the command for IBGP session. We all know this. Unicast is default also. Even if you forget to say it is going to be unicast, then why I have to mention? It became my habit. See, what I'm going to say is you can also use multicast to form VPN. But my intention is not multicast because it's BGP. It is point-to-point tunnel. I have route targets to take care of my destination, so there is no need to say multicast. But there are options to say multicast. We have an option, you see. Okay, for BGP cannot be unique multicast. See, even if you don't say unicast, it's unicast only. That's the only option. But there are some services where we use the same address family command where you will see multicast as an option. This is BGP, it's a TCP base, so there is no multicast. There is no need for multicast because I have route targets. Alright, now what is next? We have activated the neighbor. Yeah, earlier. That's all actually with the VPN configuration. If you do the same on R6, your VPN will come up. I'll go to R6. Router BGP 10, neighbor 3.3.3.3, remote AS is 10, neighbor 3.3.3, update source loopback 0, address family VPN v4 unicast. See, I don't even say unicast. It's default. Neighbor 3.3.3.3 activate. I'm expecting a VPN to come up. Have gone inside address. Yeah, see, second session is up. Second session is the VPN session. Earlier, the first session IBGP was up. Now with the same IBGP, another session has come, that is VPN. Now let us verify the VPN. Please focus. Show IPv4. Sorry, show BGP. VPN v4. Unicast. All means all VRF. Summary. We don't have VRF, but if you have VRF, it's the same command, so you have to put all. This VPN is for all VRF. Okay, you can see the neighbor is up, the status is up, but inside the VPN so far nothing is learned. VPN is ready. VPN is ready. What is next? We have to create VRF. So the second step we did was VPN v4. We have formed a tunnel between R3 and R6. Thirdly, we have to assign this interface, this wire, to a separate routing table called VRF. Likewise, this wire need to be assigned to a separate routing table called VRF. That will be the third step. VRF and interface membership. After we do this, we need to form eBGP using this VRF routing table, not the global routing table. We have a separate routing table now. If you simply do neighbor, eBGP neighbor, it will use default routing table. Via default routing table, can you reach the customer? No. So we need to use VRF aware eBGP. We need to do VRF aware eBGP. Let's do it. First, VRF. IPVRF1. That's the name that we decided to use, no? Let us stick on to this. So that there will be a sync in learning. Stick on to this example that we discussed yesterday. The names and numbers. The VRF name I have given is 1 and route distinguisher I am giving 1:1. For the same customer's remote site, if you see on router 6, I am giving different name, IPVRF2. This is to show you that name doesn't matter. That side I have said 1, this side I am saying 2. But it's for the same customer. Also, route distinguisher here I have given 1:1, there I am giving route distinguisher 11:11. This is also to prove you that the route distinguisher need not to be same. Once upon a time, when I was a beginner in MPLS, that is the time I wrote my CCIE exam. And I was not that clear with this MPLS concept when I was giving exam. And there was a troubleshooting session, MPLS troubleshooting session was the very first question. I think it was a service provider CCIE. No, I don't know. Service provider enterprise, some CCIE. This route distinguisher was not same on both sides, and I thought it is because of that MPLS is not working fine. And I was trying to match the route distinguisher. Is it a right thing that I was doing? No. I was wasting my time. The problem was just on the interface, I should say no shutdown. And I was not focusing on that simple thing. And I started comparing the VRF on router 3 and router 6. And I found route distinguisher not matching. On one side it is 1:1, the other side is 11. Just for example, I'm saying same like this. There's different number in here. So I was trying to match those things and wasting my time. You should not waste that time. That's why I'm mentioning this again. VRF name and VRF route distinguisher is locally significant to the router. Don't try to match that and waste your time if you are working in production or in exam, or if someone is discussing with you some trouble. Don't say, hey, you see, route distinguisher, you did not match. That is why. Don't say that. Then he will understand that this fellow don't know anything in depth. So it's waste of talking to this guy. Route distinguisher can be different for same neighbor. But the route target matters. Route target needs to match with the import and export. On R6, route target import I'm giving and route target export value, and we have to do the same, but only the import will become export there and export will become import. So let's do it. Here route target import is going to be 100 because there we export using 100 tag. Done. Actually, we have just created VRF, but no one is using the VRF. This is equal to you have a VLAN, but no members of VLAN. See, show IP VRF. You can see a VRF name 1 and route distinguisher, but no interface. Show VRF brief. Here, detail. Here you can see the route distinguisher, the VRF name, but no interface. And then RT value and RD value for export and import. Now I'm going to show you something which we have not configured, but they will be there dynamically configured. What is that? Show run section BGP route for BGP. You see, the send the community extended. I did not configure. Did I? No, I did not use the word community before this in this class today. But I clearly told you in the previous class. BGP community is the main reason for this VPN, but you're not going to configure it. It gets configured dynamically. That is what this I'm showing you. So these route targets that I'm using here, they are the community values. You see, you can also see communities mentioned here. So when the advertisement goes from customer on the left here, from here, a tag will be attached and the tag of export value 111:111 is attached. And when that tag matches here in the import, it downloads and gives. That's what the job of BGP community. Using community tag, using the field, the community field, using that attribute, the updates are sent. That helps to match on the remote import value and receive the update for the destination customer. Right. Now, next is, as we spoke, we have to form membership. Right now we have VLAN, but we don't have what? Interface. Likewise, we have VRF, but this interface is not so far assigned to that VRF. To assign it, this is the command. Interface G3/0. Don't put IP address. Before putting IP address, you have to say IPVRF forwarding for 1. That's the VRF. So now I can say IP address 13.13.13.3 255.255.255. No shit. Now what we have done is we have created a VRF and we have assigned the interface to the VRF. We have assigned an interface to the VRF. As a result, I should see the route in the routing table. New routing table, you see. Show IP VRF. Before that, let me show you this. Show IP VRF. You can see earlier the interface was not seen here, but now you see. Detail command will also show you. Earlier it was saying no interface, but now it shows. Show IP route will not have any gig ethernet. Show IP route don't have any gig ethernet. Gig ethernets are given to customers routing table. This is not the command to see customers routing table. Show IP route will show you only the default routing table. If you want to see the customers routing table, this is the command vrf1. You see, this is the routing table for the customer, and you can see that interface. Next, if you wish to ping the customer, is the customer's IP address. You will not be able to ping like this. Why? When you hit enter, It will try to use the routing table default. In routing table default, do you have this 30 network anywhere? Do you have 30 network in default routing table? No. So the ping won't be successful. So in order to ping, you need to use VRF. Ping using VRF 1, 13, 13, 13, 1. Now it pings. So you have to source it with the right routing table. Let us finish up to this level on R6. Going to R6. On R6 so far we have configured VRF. We need to assign interface G. Don't put IP address. First assign VRF. IP VRF forwarding. 2 is the name given. And then done. Now show IP VRF. You see interface ping 26.26.2. This ping won't happen because we are not pinging using the VRF table. But when I ping using the VRF, ping using VRF2, the ping happens. Say show IP route VRF. There is a command called star, all routing table. So it is going to show you the default routing table first. This is default routing table. And then this is routing table for customer. Separate routing table. Fine. Next is we need to form EBGP using this new routing table. How do we do that? Usually we used to say router BGP 10 and then neighbor 26, 20. I'm in router 6. Usually we used to say neighbor 26, 26, 26. No, don't do that. Why I should not do that? Because I got the neighbor in a VRF routing table, not in the default routing table. So I need to use the command address family. Listen, this is not address family VPN v4. Earlier to form VPN we said address family VPN v4. But now I am saying address family IP v4 VRF TWO2. This is to go under the BGP meant for VRF2. This BGP is not for the global, it's not for the default routing table. It's for the VRF routing table. And now I can say neighbor. Remote AS will work. Under VPN it won't work, so you need to create outside and then activate. But here it is VRF. So we are saying BGP that you will find this neighbor under the VRF2 routing table. and the neighbor belonged to 200. I'm expecting the neighbor to come up now because we have configured already router 2. Listen, it is up. And see the output here. This neighbor is via the VPN VRF2. Verify. Show IP route VRF2. I'm expecting the route to be learned. Look at this. Look at this. Beautiful. We learned 2222 via the VRF interface. Next is show BGP. Show BGP VPN v4 unicast all. You can see 22222 in the tunnel. This is tunnel command. In the tunnel, I can see, and this is given by the route distinguisher 11:11. I don't want somebody. Look at this. I'm also showing the route target that it will use to send. Focus, focus, focus. If you see here, the export value is 100. So router 6 is exporting with the community value 100:100. Did I configure any community under BGP? No. It has taken the route target. And also for that network, it is advertising a label called 21. Let us advertise another network on router 2. Show IP interface brief. As of now, we are advertising this loopback from the customer side. Let's say interface loopback 22. Router BGP 200 network. Done. So on R6, if I check, this is for router 2, which we saw earlier. Now I'm going to show you for 22. For 22 also, I see same route target, but the label is different. For each network from the customer, a dedicated new label is assigned and sent over the tunnel. Now, what is next? I'll go to router 3 and form eBGP with R1. But even here, I will see the tunnel information. You see, show BGP, VPN, v4, unicast. You can see those 22 and 2. This is coming from the remote. This is local. The VPN will have both. The autonomous system number from where it is coming is 200. So via VPN, it has reached R3. And you know very well, R4 and R5 has got no idea about all these things that we are talking. R4 and R5 has got no idea about what we are discussing. R4 and R5 has got no BGP, you see. R5. Show IP BGP, no BGP. So there is no chance for a router 5 to learn, router 4 to learn this customer route. Let us now form eBGP between R3 and R1. Router BGP 10, address family IPv4 VRF1, neighbor 13, 13, 13, 1, remote AS 100. That's it. Now I'm expecting neighbor via this VRF interface. Yeah, it is up. As a result, R1 should now know about, R1 is in the left, you see. R1 should know about 22 network and 2 network via BGP. And if I ping now 2.2.2.2 with a source of 1.1.1.1, the ping goes. You see, it's going through the VPN. How do I know? Trace route. You see, I showed you on router 6, the label for 2222 is 21. 21. And in R1, I'm showing the same label as a VPN label. This label never changes. This is the label to take traffic from 3333 to 66666. You want to see? If you go and check on R4, the label for 6666 will be 18. Let me show you. R4, where are you? R4. Show MPLS LDP, show MPLS forwarding table. 18 will be the label for 666, you see. That is why on R1 you can see this. This label is popped off before sending to router 6. 5 will pop it off before sending to router 6. And this VPN label will be popped off before sending to the customer. To the customer, it won't send any label. And we have achieved what we were hoping for in the beginning of today's session. In the next class also we are going to continue the same thing, because I want to capture a packet using Wireshark and show you these stack of MPLS. One for the transport and one for the service. The service label here is 21 and the transport label is 18. I want to show you now Wireshark packet capture. And if you have question, I'll take it tomorrow, because you should go through this video till you understand. Then you ask me question. If you have go through this video, you'll have a lot of question. If I ask now, you will ask from the day one question, MPLS day one, because you are too busy in your brain now. Too much we have seen. So go through this video, repeat it till you get it patiently. Then come with question tomorrow. After which I'm going to use Wireshark capture packet and show you a deep dive into the packets. And then what we will do is, in our next class, we'll add another customer. This is only one customer in 2 different locations. We'll add another customer and see how it works. Thanks for joining. See you later.